Hello, this is Mr. Stansbury. I'm going to take you through the notes on two variable equations. At the end of this, you should be able to say, I can create equations in two variables to represent relationships between quantities, and I can graph two variable equations. Okay, so first thing, independent and dependent variables. The value of the independent variable determines the value of the dependent variable. Okay? So, for example, let's say we have y equals 3x plus 7. If we say that x equals 4, that's what we call the independent variable because we just said we chose what that was going to be. We're going to say, okay, x is going to be 4. Okay, so when we plug 4 into this, we plug 4 into x to see what y equals, and y then becomes the dependent variable because y is depending on whatever x is to figure out what its outcome is. So if we were to do that, we'd have y equals 3 times 4 plus 7. We get 12 plus 7, so we'd get y equals 19. Okay, so y is the dependent variable because it changes depending on what we plug in for the independent variable, which is the x. So independent variable x, dependent variable is the y. Okay? All right. A linear equation is an equation whose graph is a straight line, not just a continuous line, but a linear equation has to be a straight line. Okay? Now, with that, let's take a look at an example. Okay? Luke, Leia, and Han plan to get a ride in a Coco taxi while in Cuba. A Coco taxi cost 2 CUC, which is Cuban convertible peso. Okay, so that's one of the monies that they use down there, currencies. So it costs 2 CUCs to start and 25 CUC per hour. How much would a 1 hour ride cost? And then 2 hours and then 3 hours. So a 1 hour ride, right? So if it cost $2, 2 CUC, plus it costs $25, 25 CUC per hour, so 25 times 1, that's going to give us 27 CUC for 1 hour. And then for 2 hours, we're just going to add 25 to each one of those, right? So 27 plus 25 is 52 CUC, right? That's a little hard to read. Hopefully you can. That's a 5 and a 2. Let's make that so that you can read it. Okay, that's a little better. And then if we're going to do 3 hours, just add another 25 to that. So 52 plus 25. It's going to give us, 77 CUC. Okay? So that's for A. For B, write an equation in two variables of the situation. So we're going to turn this, instead of just adding 25 for every extra hour that we're going to go, we're going to actually come up with an equation. Okay, so here's what we want to do. We want to choose any two variables. A lot of people like to choose x and y. That's in this scenario here, they did not specify what they wanted their variables to be, so you could do x and y. For me, I like to pick something that helps me keep track of what's going on. So we've got the two things that are changing is the hours, right? And then the cost. Okay, so let's do C is total cost in CUC. And then H is the number of hours that they're riding in the Coco taxi. Okay? Which is the dependent variable? Okay? So fairly important on this one here to figure out which one the dependent is and which one's the independent. So the dependent variable, basically, it depends on how many hours. The cost is going to depend on how many hours that you're writing. So the dependent variable is the cost, which in our case is C. Okay, so that one depends on the H for the hours. Okay, so write your equation. So our dependent variable, if you'll remember from before, dependent variable is usually what we put in the y spot. Okay, so what we want to do then is say C, the cost is going to equal. And then let's see, we know that it's 2 CUC to start, right, just to get into the Cocoa taxi, and then it's 25 CUC per hour. So we're going to do 25 times the number of hours. So this here can be our equation. The cost is going to equal, take the number of hours, multiply it by 25 because it's 25 CUC per hour, right? And then add the 2 CUC that it costs just to get into the Cocoa taxi. Okay? Now, check to see if your equation works. So we should be able to take our equation here. C equals 25H plus 2. And then now we should be able to start plugging stuff in. So if we plug in 1, hopefully we get 27 out. So let's do that. I'm going to, let's see, take out that H there and put in times 1. Oh, sorry, I did that in the wrong spot. I want to take this H out and put the times 1 in there. So we get C equals 25 times 1, 25 plus 2. So guess what? That gives us 27. So it works for 1 hour. Let's try it for 2. C equals 25 times, let's just plug it straight in. Now we're at 2 plus 2. So C equals 50 plus 2. So that's 52 CUC, which is what we got up here. So that one works as well. And then let's try the last one. C equals 25 times 3 plus 2. That's going to be 75 plus 2. And that is 77 CUC as well. Okay, so all of those work. So I'm feeling really good about our equation that it is correct because it worked for all 3 of the ones that we had already calculated out. Okay, and that's really I really think that's a pretty important thing to do when you're going through and trying these out. It's really important to double check to make sure your equation works. So plug it in with at least a couple of different ones just to make sure that it works. Okay? All right, we are going to move on to part C. Okay, but before we do that, let's take a quick little comedy break.
Okay.
All right. C, how much did it cost for a 3.5 hour ride? So we will simply plug that in, right? 25 times 3.5 plus 2. Okay, I'm not great at 25 times 3.5. Let's try that. 25 times 3.5 gives us 87.5. Plus 2 more is 89.5 CUC for a 3.5 hour ride. Okay, now graph our equation. Okay, so here's what you want to do to graph your equation. Choose appropriate values for each axis, graph the y-intercept, graph more points, and then connect those points. So let's see, we did 3.5 and it's already up to 89. So let's see, this is going to be our independent variable. Let's see, that's going to be the hours. Oops, let's do this a little lower down so we've got a spot to put our stuff in. Hours. So we could do, like, say, I don't think you're going to want to take a 10-hour Cocoa ride. So let's do this. Let's do 0, 1, 2, 3, 4, up to 5 here. And then we're at 3 and we're already at almost 100. So let's do this. Let's do this up to, say, 200. So this would be 100. And this is price in CUC, right? So let's see. This is going to be 20, 40, 60, 80, 10, 100, 100, let's see, we're going by 20s, 120, 140, 160, 180. We don't have to label every single one. As long as you kind of got the scale down, we should be good. Okay, so we choose appropriate values for each axis, graph the y-intercept and more points, and then we could even give this, probably wise to start getting in the habit, give this thing a title. So cost for a, what was it, a coconut? What's that thing called? A cocoa taxi. Let's see, let's move it up far. Cocoa taxi ride. Something like that. Okay, so we know that, well, let's see, 0 hours. It costs 2 CUC just to get in. So our y-intercept here is just above. It's not going to actually be at 0. It's going to be the 2 CUC just to get in. And then for 1, we are at 27, right? So that's 20, that's 40. So that's going to be somewhere up just a little below that. For 2 hours, we're at 52. All right, let's see, that's 40, 52, a little bit higher up there. 3 hours, we were at 77. So that's just under 80. Okay, and since we had 3.5, we might as well try that one. That's 89.5, so just under 90. So 3.5 was just about right there-ish. Okay, so we've graphed our y-intercept. We've graphed more points. Probably don't need to graph all those points, but I thought it might not be a bad idea to take a look. Okay, and then we connect our points. So simply start with the y-intercept and then connect all those points. And it should hopefully make a nice linear graph here. As you can tell, it's not perfect just because we don't have our scales great on there. Anyway, so we can kind of estimate here that a 5-hour cocoa taxi should cost a little over 120 CUC, probably about 125 or so. Last two things here, what does the y-intercept represent in this situation? That's the cost to get in the cocoa taxi, basically the startup cost, right? Okay, and what does the slope represent in this situation? That is the cost per hour to ride cocoa taxi, right? In the cocoa taxi. Okay? Okay, that's all we have for you here. So if you have any further questions on this, please feel free to ask. Okay? Thanks.